All right, you ready? Two more formulas. Here we go. Today we're going to learn how to determine molar mass and how to determine the density. And we're going to use the same variables that are in the ideal gas law. So remember the ideal gas law? PV equals nRT. And remember, R is equal to 0.0821, and Latham riding a camel. We're going to use the same R today, but today we're going to determine molar mass, which will be represented by the capital letter M. And we're going to use density, which will be represented by the lowercase d. So the first formula is for molar mass, and that formula is molar mass equals mass of the sample RT over PV. So that little m is equal to the mass of the sample. In grams. So remember, molar mass is equal to grams per mole. So now we have grams, which isn't going to get canceled out because R is going to do all the canceling, and that's Latham riding a camel. So Kelvin is going to get canceled out, ATM and liters. So what's going to be left is Latham riding a camel. Moles on the bottom and grams on the top. So that's going to give you grams per mole for your molar mass. So this is one formula. For density, your formula is going to be molar mass, grams per mole. And remember, density is grams per volume. So grams per mole, pressure, over R and T. So what that's going to do is your R is going to cancel out your moles, your ATM, your Kelvin, and it's going to leave your liters. So you're going to get grams from the grams per mole over liters, which is going to give you your density. So that is going to give you your density in grams per liter. Meanwhile, your molar mass up here is going to be grams per mole. Okay? All right, so let's get started on some sample problems. We'll just do a couple. Let's get started on a molar mass problem. All right. Okay, so problem number one. A sample, a 0.30 gram sample of a gas has a volume of 82.0 milliliters at 3.00 ATM and 27 degrees Celsius. Calculate the molar mass. All right, so we're going to be using molar mass is equal to mass of the sample, RT, over PV. This is Mr. T over PV. See, Mr. T over PV. That's how I remember it. Molar mass equals Mr. T over PV. Okay. Now, so my lowercase m is equal to 0.30 grams. My R, we know, T is equal to 27 plus 273. So that equals 300 Kelvin. My pressure is equal to 3.00 atm. And my, what's left? Volume. Volume is equal to 82.0 milliliters, or it's equal to 0.0820 liters. All right, so here we go. My molar mass is equal to 0.30 grams times 0.0821. Glad I'm riding a camel. Times 300 Kelvin all over my pressure, which is 3 atm, times my volume, 0.0820 liters. My liters cancel, my atms cancel, my Kelvin cancels, and I'm left with grams over moles. So when I calculate this, I get 30, basically. 3.0 times 10 to the 1. So I get 2 digits, right? So I get 3.0 times 10 to the 1 grams per mole. That's the answer. Okay, example 2. Calculate the density of sulfur hexafluoride at STP. All right, so STP, we have temperature, 273 Kelvin, pressure, 1 atm, right? So that's all I need, right? I guess I could just put in a volume. Let's just put in 1 liter. See what happens, right? Okay, so I need my molar mass of this. Because remember, the formula here is density equals molar mass times pressure over RT. Oh, I don't even need a volume. No volume needed. Okay. Molar mass times pressure over RT. So I have that. I have everything. I just need my pressure, my molar mass. So I'm just going to add this up. 32 and then 6 times 19, which is equal to 146. So I add these together. 114. 114. And then I add these together and I get 146. So that's my molar mass, right? Okay, so my density is equal to molar mass, 146, times my pressure, 1 atm, because I'm doing it at STP, over R, 0.0821 times temperature, 273. Okay, now I'm going to do my calculator. 146 times 1 divided by 0.0821 divided by 273 equals 6.51. But I only get the 1 atm is a count. It's like at standard pressure, so it's 1. So I get 3 digits. So 6.51. 6.51, and then my units, remember, so I have grams per mole, but the R is going to cancel the moles, and then I have pressure, so cancel atm, cancel Kelvin, and I'm left with liters, so grams per liter, and that's going to be my density. All right. Okay, let's do one more problem, and then we're all done. So the last problem is, I have an unknown gas unknown gas that has a density, right, a density of 3.167 grams per liter. At STP, P, that's not a B, P. Okay, what is its identity? Now, I'm going to give you a couple suggestions, all right? And we're going to try and match it. Is it argon, O2, Cl2, H2O, or HF? So these are your choices, all right? So in order to do this, we probably want to find the molar mass, all right? So the formula for molar mass is the mass times RT, the mass of the sample, times RT over PV. Okay, so what if we said in this case, because here what this is 3.167 grams for 1 liter. So what if I said I have 3.16 grams of it and I have 1 liter? Then that gives me moles, grams, and volume, right? And I know my temperature, so that means the mass of my sample is equal to 3.167 grams. The volume of my sample is 1 liter, right? The pressure of my sample is at STP, so that's 1 atm. See that? Because grams per liter. 1 atm. The temperature of my sample is 273 Kelvin. And now I'm ready to go, because I know R is always the same. So my molar mass is equal to 3.167 grams times R, 0.0821, glad I'm writing camel, temperature 273 Kelvin, all over pressure 1 atm, volume 1 liter. Oh, that's pretty easy. All right, so let's give it a try and see what we come up with. 3.167 times 0.0821 times 273. And I get 70.98. So the molar mass is equal to 70.98 grams per mole. So now what we're going to do is we're going to compare this to the molar masses of argon and of all of those molar masses. So the molar mass of argon is 39.9. So nope, that's not it. The molar mass of oxygen is 16 plus 16, so that's 32. So that's a no. The molar mass of chlorine is 35.45 plus 35.45. Oh, that's 70.98. Bloop. So it must be that. Chlorine. Okay, pretty cool, huh? All right, so go do your homework now in the other module. All right, a couple of these problems and maybe some other problems from Friday. And so if you didn't work there Friday, you're gonna want to watch the video. All right, and I will see you tomorrow. Submit your homework today to today's homework. You're gonna want to, oh no, bring that to class tomorrow. All right, okay, I'll see you Tuesday. Don't forget to submit the homework that's due today. That's got to be submitted online today. All right? Okay.